Right, so this is the Year 11 chemistry topic on ionic bonding, okay? So the fact that we've got quite a lot of core knowledge questions up today is really important because they are stuff that you need to think about before we start even trying to attempt to ionically bond, okay? So on your sheet of paper, however you're doing it, I want you to write the date, and I've left a little gap for you to write whatever your date might be. The title, which is ionic bonding, and the keywords, okay, because they're words that we're going to be using. It's really important to practice your scientific literacy. What I then want you to do is to pause the screen and have a go at answering the 6 questions, okay? They're not really hard. They're stuff that we've done before. You should be able to answer them, okay? If you can't, then you need to go back and have a think, Google, or just wait for me to answer them. Right, so question number 1 says to draw and label an atom, okay? You will get so bored of doing this question, but it's so important to keep thinking about what is inside an atom, which bits are where, okay? So here's just a quick one I've drawn. The electrons, okay, are on the outer, well, on the shells, okay, and they have a negative value, okay? They have a negative value. You've got the neutrons, okay, so neutrons have no charge. And then you have got your positive protons. Okay. Next question then says, name this number. So this number is the mass number. Name this number. That is the atomic number, okay? Remember, the mass number is the massive number, okay? Mass number means massive. Number 4, what is this called? Well, this is an element. I understand if some of you had written oxygen, because that's what it stands for, but I just want you to think, because that's what you'll get on your periodic table. That's what you get on your periodic table, so I just wanted you to think about all the different parts, okay? What can we use the mass number to work out? Okay, well, the mass number tells us the number of protons and neutrons added together. Okay, so I've just wrote P and N. What can you use the atomic number to work out? Well, you can use that to work out the number of protons, which is always equal to the number of electrons. Okay, so what we're going to do now is we're going to have quite a quick recap, hopefully it'll be quick, on the electronic structure of certain elements. So I'm going to go back through electronic structure. You should have done it year 9. But we're going to have a quick go. Okay, it's also in year 10. And then we're going to move on to a little bit of a tougher topic, which is ionic bonding. So just a quick recap, we've just done this today. Okay, so the mass number is the number of protons and neutrons. The atomic number is the number of protons or electrons. Remember, to work out neutrons, you just take them away from each other. But what is important to us today is the atomic number, which is a smaller number, which gives us the number of electrons, because we're going to focus on electron structure and then ionic bonding. So electron structure, all electrons orbit in the shells around the nucleus, but they have a special arrangement, okay? So not all electrons, say you've got 10 electrons because you've worked that out from the atomic number, they can't all go in the first shell, okay? There's a really important way of how they go in the shells, and you need to know it. Normally, we only work with the first 20 anyway, so it's 2, 8, 8, 2. You only have to be able to do the first 20, okay? You don't have to be able to do any more, okay? And don't worry, some of them don't quite fit if you go lower down. That's because they aren't in the first 20. So we only ever focus on the first 20, being able to put them in their shells, okay? The big thing to remember is that only 2 go in the first shell, okay? So I'm going to have a go at 2, and then you're going to have a go at a couple, okay? So we're going to do oxygen first. First thing you have to do is find the atomic number, okay? Remember, the atomic number is the smaller of the 2 numbers, okay, which tells you the number of electrons. So I know that I have got 8 electrons, okay? Then I want you to draw a nucleus, okay? We're just going to draw a nucleus as though it's a black dot. Sometimes you see it with the letter of the element, but oxygen's a bit hard because it looks like an O. So we're always going to draw the nucleus as though it's a black dot, okay? And then we're going to add our first shell, okay? Draw the electrons in the first shell, okay? So only 2 electrons can go in the first shell. So I'm going to draw them as crosses, and I'm going to think about my placing of them, okay? I'm not going to group them together. I'm not going to do that, okay? I'm going to spread them out. Normally, as though you're at 12 and at 6:30, or 12 and 6 on a clock, okay? Nice and spread out. Okay, move to the next shell. Now, first what I need to do before I move to the next shell is I need to think about how many electrons I've got left, okay? So I started with 8, I do 8, take away 2, I've got 6 electrons left, okay? So 6 electrons left now to go in my next shell, okay? What I'm going to do is I'm not going to pair them up until they need to be paired up, okay? So I've got 6 electrons left, I'm going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I've only got 4 now. 8 can fit in this shell, so I'm then going to pair them up. So I'm going to do 2 there and 2 there. You've still got 2 that are unpaired, but that's fine because you've got 6 electrons in your next shell, okay? So make sure you're focusing on that. Sometimes you'll have to draw another shell, but don't worry about that because the oxygen doesn't need that. Count the number of shells. So the number of shells, you've got 1 shell, 2 shells, so that means it's in period 2. If I was looking on the periodic table, it would be in period 2. Count the number of electrons in the outer shell. So I've got 6 electrons in my outer shell. That means it would be in group 6, okay? So that allows me to find it on the periodic table. So I go period 2, go 1, 2, down, and then I go across to find group 6, okay? The numbers for group 6 will be at the top. So that's the first one. I'm going to have a go at another one. Might be useful for you to follow through and have a go at this one, okay? And then I'm going to leave you to have a go at quite a few. So, first thing we need to do is find the atomic number. The atomic number is the smaller number. So this time, I've got 12, okay? Draw the nucleus. Remember we spoke about how we're going to do our nucleus as a dark circle. And then I'm going to draw my first shell, okay? How many can fit in my first shell? 2. Remember I said nice and spread out, so we do them at 12 and 6, okay? Next thing I then need to do is do 12, take away 2. I've got 10 left, okay? How many can go in my next shell? Only 8 can go in my next shell. So I draw another shell and I fit the 8 in. Remember, we're thinking about a clock. Do not pair them up until they need to be. So 12, 3, 6, 9. That's only 4. We know 8 can fit in this shell, so go around again. I've now put 8 out of my 10 in that shell. So 10, take away 8. I've got 2 left. So I draw another shell and I put 2 in. Okay, you don't have to do them. You could, that's just thinking about spacing them out. I think, okay, it's gone like that. So we're going around our circle. Okay, so make sure you're counting, remembering how many can fit in each shell. Count the number of shells. So I've got 1 shell, 2 shells, 3 shells, okay? So my period is going to be period 3. Group, how many have I got in my outer shell? So I've got 1, 2 in my outer shell, so I'm going to write 2. So it's in period 3, group 2. What I'd like you to have a go at now, and you don't need a periodic table because I have given you the atomic numbers, so the smaller numbers, okay? Given you the smaller numbers, I'd like you to have a go. It might be quite useful to maybe pause on this screen, so go back and pause on that screen, thinking about how you draw the electronic structures for these, okay? Right, so you should have now had a go at them. I'm going to put up the next screen, so it might be useful for you to maybe pause to check your answers. So, ooh, they're moving around. So, neon. Neon is in group 0. Okay, you might remember from the last year. You can see why you think it would be in group 8. Okay, it's the noble gases, the ones on the end. They've got full outer shells. They're really stable. Okay, neon is in period 2, and you can see that I've drawn them. Make sure you're doing the crosses like that, so you can kind of count them to make sure you're doing it right. Chlorine then is in group 7 because it's got 7 in its outer shell. Period 3. Hydrogen, bit of a funny one. It's in period 1. You wouldn't really say it's in group 1. Okay, it's kind of on its own. It's like in the middle of the periodic table. Little bit of a strange element. Okay, I can understand why you think it was in group 1, and you write group 1 if it was asked of you, but it's not really in group 1. It doesn't have the same properties as though it was in group 1. Sodium then is definitely in group 1. It's got 1 in its outer shell. It's in period 3 because it's got 3 shells. Ooh, there we go. And then potassium, where my circle's gone a little bit funny at the bottom there. Potassium then would be in group 1 again, but it's in period 4 because it's got 4 shells. Okay, they're not perfect drawings, okay, because I'm obviously just drawing with my pen like you would be. Don't worry about getting the circles exactly perfect, but hopefully we're all alright. There we go. All alright with that, okay? So again, if you need to pause the screen just to check your answers, that's great. So, what you need to remember now to move on, so we've done electronic structure, what you need to remember now to move on is that atoms like to have full electron shells. They want to be like neon. They want to be like neon. They want to have a full outer shell, okay? So, they want to have a full outer shell. So what is ionic bonding? Ionic bonding is when a reaction occurs between a metal and a non-metal, okay? Metals and non-metals have incomplete outer shells. So the metals are in group 1, group 2, cross group 3. So if they're in group 1, they've only got 1 electron in their outer shell. If they're in group 2, they've got 2 electrons in their outer shell. They're really unstable. Okay, the same if you're in group 7, which is a non-metal. You need 1 more, but you don't have a full outer shell. Okay, remember to have a full outer shell. Mostly you need 8. Okay, some only need 2, like hydrogen only need 2 to be full, but most of them need 8. Okay, so you're looking to either lose or gain an electron to become 8. Okay, positive and negative ions are strongly attracted to each other. This electrostatic attraction is called an ionic bond. So the attraction between a metal and a non-metal, they attract together, they bond together, make a really strong bond, but they also end up with, technically, full outer shells because they've either lost or gained an electron. Okay, so ionic bonding, kind of like shown in this picture. So sodium is in group 1, so it's got 1 electron to lose, and then it would have a full outer shell. So if it didn't have this electron anymore, if you notice, the next shell's got 8, so it's got a full outer shell, okay? Chlorine's the same, we've just done chlorine, it's got 7 in its outer shell. Again, if it transferred that electron, it would then have got a full outer shell as well, okay? So electrons from one atom are shown as dots and the other is shown as crosses. For example, when sodium reacts with chlorine, electrons transfer over, okay? And then sodium will have lost an electron, so it will become positive, and chlorine would have gained an electron, so it would become negative, okay? So just a quick true or false now, all about what ionic bonding is. So you should have all had time to pause the screen and have a go at the true or false. Obviously, your challenge here is to correct them. So ionic bonding is the sharing of electrons. If we go back to this picture, they aren't sharing electrons. It is the transfer. Okay, so review 2 on your piece of paper. It is the transfer of electrons. Okay, so that one would be false. Ionic bonding happens between 2 non-metals. Again, that is false. It is a metal and a non-metal. Okay, so ionic bonding only occurs between a metal and a non-metal. Ions are not formed. Again, that is false, and we talked about this here. Ions are formed. You get positive and negative ions, depending on whether you're an element that has lost an electron or you're an element that has gained an electron. Okay, so ions are formed. Losing an electron means you are a negative ion. That is false. Oh, they're all false. Interesting. Gained an electron. Okay. Think about it. Electrons are negative, so the more negative you are, the more electrons you have technically gained. So to become a negative ion, you've got to gain electrons, which is a bit hard to get your head around, because you think, oh, I've gained something, I've automatically got to be positive. No, because you've gained something negative, okay? And the more we practice this, don't worry, the easier that kind of statement will become, okay? So to gain an electron, you become negative because electrons are negative. If I gain protons, which can't happen, then I become more positive. Now, the reason you become a positive ion is because you've lost electrons. You've got rid of your negative features. Right, so we're going to have a go now at drawing out how you ionically bond, okay? So work out the atomic numbers of the electrons. I'll obviously put the periodic table up. I'm going to do this one, I think another one, and then you're going to have a go at a couple, but I'll put the periodic table up at the end of this PowerPoint on Teams so you can use it. Remember the atomic number, thinking back to the electron structure stuff we did at the beginning, the atomic number is the smaller number. So sodium is 11, chlorine is 17, okay? work out the electrons in the outer shell. So there's two ways to do this. Okay, so we've got our atomic number. Now we want to work out the electrons in the outer shell. So there's two ways to do this. Okay, you can either look at the group number, which is nice and easy. So sodium's in group 1, chlorine's in group 7. So sodium's got 1 in its outer shell, chlorine has got 7 in its outer shell. The other way to do it is just to kind of, you can either draw it out, you'd be there for ages, or just look at 11 and think about it. So 2 will go in the first shell, 8, 1. Okay, might be useful to do that because at the end they ask you to think about their electronic structures. So chlorine would be 2, 8, 7. Okay, so I've worked out how many are in my outer shells. So the next thing I need to do then is draw their outer shells. Okay, so you're going to do 1 with crosses. Okay, so I've just drawn its outer shell, it's got 1, and I'm going to do chlorine then with dots, and it has 7. I've drawn my nucleuses in the middle. Okay, so I've got chlorine by here, just its outer shell, sodium by here, again, just its outer shell. Okay, which way will they transfer? Okay, so it's easier for sodium to lose this 1 electron and transfer it over here, okay, than it would be for chlorine to lose 7 electrons, okay? So sodium's going to lose 1, chlorine's going to gain 1, okay? If it was the other way around, you'd be there forever. Chlorine would have to lose 7 electrons to get a full outer shell. Remember, they want to have a full outer shell. What you then need to do is draw the transfer of electrons, which I've just done. Draw it so you can show the examiner that you know which way they're transferring. So you can show the examiner which way they're transferring, okay? So draw the transfer of electrons, work out, and what I would suggest you do is draw what they'd look like now. So sodium is kind of just going to look like that because it's got an empty shell. Chlorine is going to have that extra electron now. Okay, so draw them how they look now, okay? So sodium, has it lost or gained an electron? It's lost an electron. It's only lost 1, so it's going to become positive 1, okay? It's lost something negative. Chlorine has gained an electron, so it's going to become negative 1, okay? And then you have to write out, because it's formed a bond, its new ionic formula. So you've got 1 sodium, remember the metal always goes first, and then 1 chlorine, nice and easy, okay? The next thing you need to do, and this is why I said it would be good to write out the electronic structure at the top, be quite useful to write out the electronic structure. So sodium has now lost that electron, hasn't it? So sodium has lost that electron. So it's not actually going to be 281 anymore. Its new electron structure is just going to be 28, okay? Chlorine has gained that electron, so it's turned from 7 to 8, so its new electron structure is going to be 2, 8, 8, okay? That's most probably one of the harder things you've got to do, but they sometimes ask that in the exam, and most people will write 2, 8, 7, because that's the electron structure of chlorine, but they're asking you for the new electron structure, okay? So what's happened when it's gained an electron, okay? Or lost an electron. So we're going to have a go at one more now. This one's a little bit harder, okay? A little bit harder, okay? So magnesium, going back to the beginning, first thing, magnesium has an atomic number of 12, okay? Magnesium has an atomic number of 12. Chlorine, because we've done it before, has an atomic number of 17, okay? Just move it down. Okay, has an atomic number of 17, okay? So work out their atomic numbers, or the number of electrons, okay? Again, magnesium's in group 2, chlorine's in group 7, but it is good practice to go 2, 8, 2, 2, 8, 7. Remember, because you are going to need the electron structure, okay? So once we've worked them out, you can either draw the dot for the nucleus, which I did before, but I think it might be good to write magnesium in the middle. So Mg, it's got 2 in its outer shell, going to give it crosses. Okay, chlorine, got 7 in its outer shell, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. and again, okay? Now, straight away, you can kind of see where chlorine needs to gain, okay? Chlorine cannot lose 7 electrons to get a full outer shell, but it could gain 1. So say it's gaining this one from magnesium, okay? So it's gaining 1, okay? But if you notice, magnesium doesn't have a full outer shell now, does it? It's still got 1 left to lose to have a full outer shell. So it needs to lose 2 to get a full outer shell, okay? So what we would do, and you're allowed to do this, okay, is you would say, I need another chlorine. So 1, 2, 3, 7, okay? So I need another chlorine. That other chlorine now can take my second magnesium, okay? So which way will they transfer? Draw the transfer of electrons. Like I said before, I'm just looking at my screen, I'm going to draw it down below, okay? Like I said before, it's good to then kind of like, you'll have more space because you'll be doing this on sheets of paper, to draw out. So magnesium looks like this now. It's got a full outer shell, it's empty shell. Now you've got 2 chlorines that look like this. Okay, remember we're just drawing the full outer shells. You can draw all the shells if you want, but you'll be there forever with some of them. Because it's taken the electrons from magnesium. Okay, so work out the ions. Magnesium has lost 2 electrons. It's lost 2 electrons, so it's going to be positive 2. Okay, it's lost 2 electrons. Chlorine, and this is why it's important to draw out both of them, because chlorine, each chlorine has only lost 1 electron, so they're just negative 1. Okay, write out the ionic formula. How many magnesiums do I have? How many magnesiums do I have? I have 1, so I write Mg. How many chlorines do I have? I have 2 chlorines, okay? 2 chlorines, so I do Cl little 2, okay? Remember, we don't do Mg2Cl or MgCl2, okay? We practiced that before, it's a little 2, okay? New electronic structures, the last little thing to do now. New electronic structures, 2, 8 for magnesium, because it's lost them 2. Chlorine, so each chlorine would be 2, 8, 8, okay? Because they've each gained 1 electron, okay? So, if you are feeling no, actually, I'll tell you what we're going to do. What I'd like you to do is press pause and have a go at this one, okay? Press pause, have a go at this one. I'm going to put the answers up for this one in a minute, once you press pause. And then you can either go back maybe and watch the 2 again, or you can move on and do the assessment. Right, so you've most probably had a go to do this one, so I'm just going to check that we're all on the same page before I put the assessment question up. So work out the number of electrons. So potassium has 19 electrons, oxygen has 8, okay? Again, you can work it out, potassium's in group 1, oxygen's in group 6, but I would practice doing this, so it would be 2, 8, 8, 1, oxygen would be 2, 6, okay? Remember to draw them, potassium is K, so if I was just drawing its outer shell, I'd do 1, so I've done that one as a dot. So oxygen then, that's why oxygen's hard to do, because if you do the element symbol in the middle, it looks a bit weird. So it's going to be 1, 2, 3, 4, 5, 6. So if we got to this stage, we're off to a really good start, okay? So we've drawn them out, we know exactly what they look like, okay? The next thing we need to do is work out which way they transfer to get a full outer shell, okay? So the metal, which is potassium, because it's in group 1, always transfers to the non-metal, so potassium is going to transfer over here. So potassium now has a full outer shell, but oxygen doesn't, does it? So remember, this is the only time we can ever do this, is just to add our own extra elements, not just random elements. You can only add potassiums or oxygens to make sure that you've got your full outer shell. So again, we're going to transfer that across, okay? So this time now, we've got 2 potassiums. Both of our potassiums have now got full outer shells, because I'll have 8, okay? But you can just draw them as though they've lost their electrons, okay? Oxygen then has gained 2 electrons, so 1, 2, 3, 4, 5, 6. That's what it looked like before. Now it's gained 2 electrons. 1, 2. Okay? So, potassium, each potassium has lost 1 electron, so it's going to be positive 1. Remember, you've got each of your potassiums, okay? Oxygen has gained 2 electrons, so it's going to be negative 2, okay, because it's gained 2 electrons. Write out the ionic formula. So you've got K2, because there's 2, okay? Remember, it's a little and then big O, okay? There's only 1 oxygen. Electronic structures, so each potassium is going to have an electronic structure of 2, 8, 8, and the oxygen is going to have 2, 8, because it has gained 2 electrons, okay? So, if you got that right, what I want you to do is go on to this page, pause the screen, it's obviously going to be on Teams, and have a go at the rest of them. I'll put a periodic table up so you can work out their atomic numbers, okay? There's also a challenge one, aluminium chloride, that's quite difficult, and there is like a super challenge, here to like Google the properties and work out when they can conduct electricity, okay? So there's loads of stuff to be doing, okay? Put the success criteria there, so if you just want to pause the screen and have a go. Now, if you are not sure and you didn't get the right answer there, okay, I want you to go back and watch me do the 2 we do's again, okay, the I do and the we do, okay? And then I just want you to, if you're still not sure, have a go at 1, okay? You can email us, contact us on Teams. There are loads of ways to make sure, okay? Make sure you upload your work, and if you upload it beginning of the week, then we can check it, okay? Thank you very much, and I'll see you soon.